this video here looking at empirical formula. So what an empirical formula is, empirical formula is the simplest whole number ratio of atoms in a compound. So examples, it's pretty much, can you reduce the molecular formula? So H2O I can't reduce, so that is the simplest ratio. If it's hydrogen peroxide, H2O2, I can reduce that to 1 to 1. So there's my empirical formula, different from my molecular. C4H10 I can reduce by half, so C2H5, and then this one, 6 and 6 I can reduce down to 1 and 1. So simplest whole number ratio, no fractions or anything like that, is what we have there. So to determine a substance's empirical formula, we need mass, so grams, I give you data for that, or you're going to need percent composition data. So that's why we talked about percent composition first. But we need one of those two things for each element in the compound to do these problems. So once you have that, what you're going to do is you're going to convert mass of each element to moles of that element. You're then going to find the ratio by dividing by the smallest number of moles. So important step right there. Make sure you divide by the smallest number once you find them. And then you're going to use that ratio to write the empirical formula. Sometimes that ratio isn't going to come out to be a whole number. And again, by definition there, empirical formula is the simplest whole number ratio. So if you do get a ratio where you have a quarter, well, you're going to multiply by 4 to get rid of it and get a whole number. If you get a third, you're going to multiply by 3 to get rid of it and get a whole number. And if you have a half, you're going to multiply by 2 to get rid of it and get a whole number. So like if you had a ratio of, trying to think of one here, like into 2.5, like let's say that comes out to be a ratio, multiply by 2 to get rid of the half, but if I multiply this by 2, I also have to multiply this by 2. So my empirical formula would be N4O5. Again, I can't reduce that, so it is the simplest whole number ratio. This would then be my empirical formula. Alright, so example 1. A compound is found to contain 9.11 grams of nickel and 5.89 grams of fluorine. Find its empirical formula. First step, convert grams to moles. So I have 9.11 grams of nickel, and I want to convert to moles. So I'll go to my periodic table. Nickel has a molar mass of 58.71 grams per 1 mole. Plug that into my calculator. 9.11 divided by 58.71 is 0.155. And that's moles. Keep a couple sig figs. 3 is probably a good number, 3 or 4. Anything less than that, you're going to run into an issue where it's going to be hard to cancel. So the more sig figs you have, the better. 3 or 4 is a good number for this. We're going to do the same thing for our other element, 5.89 grams of fluorine. I want to convert to moles. Well, fluorine is one of those diatomics. However, diatomics are only when they're by themselves in a formula. Well, here it's a compound. It's a compound of nickel and fluorine. So I'm not going to use the diatomic form. It's bonded to something else. So fluorine, 19 point, driving me crazy, 0.00 grams in 1 mole. Do the math, 5.89 divided by 19 gets me 0.310, 3 sig figs there. So that's step 1, convert to moles. Step 2, divide by the smallest number, 0.155 is 1, divide by 0.155 is, in this case, 2. So this is my mole ratio. So for every 1 nickel, so there's 1 nickel, I have 2 fluorines. Whole number ratio, right there is my empirical formula for nickel and fluorine. Question 2. Well, what if you're given percent composition data? Key to this is, well, we need to get to grams if we're going to convert to moles. So make it easy on yourself. Since we have mass percents or percent compositions, assume 100 grams. What that does is that it just allows you to change the percent to grams, and it looks just like the last problem. So if I assume 100 grams, well, then this is grams, and this is grams. So we start just like we did in the last one, 36.84 grams of, in this case, it's nitrogen. So again, it's a compound of nitrogen and oxygen, so I'm only going to use 14.00 and not the diatomic in 1 mole. And then for the other one, 63.16 grams of oxygen. Again, yes, it's diatomic, but in empirical formula, I don't have to worry about that because it's not bonded to itself. It's bonded to someone else. Moles. Look at my math here. All right, 36.84 divided by 14 gets me 2.63 moles. On bottom, 63.16 divided by 16 gets me 3.95, if I round, moles here. Divided by the smallest number, that's a 6. .63 is 1 divided by 2.63 is, in this case, 3.95 divided by 2.63 gets me 1.5 to a third sig big 0. So what I have in this case, I have for every 1 nitrogen, I have 1.5 oxygens. Well, that's not the simplest whole number ratio, so I got to get rid of it. So to get rid of a half, I'm going to multiply by 2. But to multiply that by 2, I also have to multiply that by 2. So what I have is N2O3 as my empirical formula. Example 3. A compound with a mass of 4.97 grams contains 3.24 grams of arsenic that has reacted with oxygen. Find its empirical formula. Some of you are probably just going to want to jump right in and convert this to moles, and go from there. Here's the only problem. Slow down. This says the compound has a mass of 4.97. This is how much arsenic I have. It never actually tells me how much oxygen. However, if I know that this is the mass of the compound and it's only made of 2 things, arsenic and oxygen, well, if I know the mass of one, I can find the mass of the other. So subtract to find the mass of oxygen. So read carefully. 4.97 grams of the compound minus my 3.24 grams of the arsenic. I get 1.73 grams of oxygen. So now that I have the mass of each element, I can convert to moles, do all that stuff. 3.24 grams of arsenic converted to moles. Arsenic 74.92 in 1 mole. Does not like my writing. Oxygen 1.73 grams of oxygen is 16.00 in 1 mole. Again, not diatomic. Well, it is diatomic, but it's bonded with something else, so we don't have to worry about that. Do some math. 3.24 divided by 74.92 gets me 0.43 2 moles. The bottom one, 1.73 divided by 16, gets me 0.108 moles, divided by the smallest number, 0.108. Divided by 0.108. 1 up top, 0.43. Did I do that right? 3.24 divided by 74.92. Oops. 0.24 divided by 74.92 is 0.043. So I messed up here. My decimal needs to be here. That's my smallest number, 432. In this case, it's 1. Divide this by 0.4. 32 with the decimal in the correct spot. So 0.108 divided by 0.0432. In this case, I get 2.5. So what that says is, for every 1 arsenic, I have 2.5 oxygens. Again, I got a half, so I got to multiply by 2 to get a whole number. Not only there, but also here. Empirical formula, As2O5. So diarsenic pentoxide for my empirical formula there. And that is how you calculate empirical formulas.